Good evening, everyone. So, good evening, everybody. Yes, my day is good. What about yours? Probably last days of us, in fact, to say last week of us to hold up, and it's been around 45 days. We have started our classes. So, from the past 45 days, I think around last month, yes, right, 10th. In July 10th, I think we have started the session. July 10th or 11th, we started the sessions for the open channel flow, and later on immediately we started with the geotechnical engineering. Okay, so within a few days, I think 3-4 days, open channel flow 14 days, right? It's not 20 days. Open channel flow was 14 or 15 days. I mean, when did we started open channel flow? When did we started open channel flow? Like I didn't remember exactly when we started. Let me check that. Yeah, we started open channel from 14th. So open channel flow we took up to 12 days, and 27th onwards I think we have started. 25th onwards we have started a geotechnical engineering. So anyways, overall around 45 days, right? By this, yeah. Yes, yes. Yeah. So now let's come to the bearing capacity. See, we discussed about the analytical analysis or numerical analysis by means of Terzaghi's theory, Meyerhoff theory, and all those things. Now, in order to determine this ultimate bearing capacity or ultimate load carrying capacity, in fact to say, we are going to do a test known as a plate load test. Now, the plate load test. Okay. So the plate load test this plate load test, you see, in the case of the plate load test, what we do is, for example, you see, what is the meaning of ultimate bearing capacity? The meaning of ultimate bearing capacity is nothing but the maximum pressure that the soil can take without any failure. Yes. So for that, to find out the ultimate bearing capacity, do you think you are going to construct the actual foundation and then you are going to apply the load through that soil, means through that column and through the foundation, and you imply or you increase the load, increase and wait till the foundation is going to be failure? And you know that at a failure, whatever the pressure you apply is nothing but ultimate bearing capacity. But are you going to do the experiment by constructing the actual foundation? Are you going to do the experiment by constructing the actual foundation? No, right? We are not going to be construct, means we are not going to be do the experiment on yeah, on the actual foundation. So what we do is, instead of constructing the actual foundation, what we do is we replicate the foundation into a plate. Whether the plate can be a circular plate or a square plate. So we assume, or we replicated the prototype is a foundation or footing now, and we are making to a model as a plate, which can be either square or either square or circle. So what is the purpose of this load bearing test or plate load test? To determine, number one, ultimate bearing capacity of soil. Number two, allowable pressure for safe settlement. Okay, so we are going to find out the ultimate bearing capacity and allowable pressure for the safer settlement. Let's see how we are going to conduct this test. Let's see how we are going to conduct this test. See, generally we know that if we dig a foundation, see, generally we know that, so if you go for excavation, if I go for the excavation, so this is a normal foundation that we construct. Yes. So this is a foundation or footing whose width is going to be B. Whose width is going to be B. So what I am going to do here is instead of using the footing on the soil, I am going to keep a plate. So this footing is replicated to or replicate it to a plate. A plate. Whether the plate can be square plate or circular plate. So if you see, it can be a what I say, square plate, so this is a square plate. So now it can be a square plate of dimensions BP, BP by BP, or it can be a circular plate also. It can be a circular plate. So in this test, instead of constructing the actual foundation, we replicated the footing as a square plate or circular plate. And in the case of the circular plate, whatever the dimension, the dia of the circular plate, you can observe this is nothing but dia of the plate. Okay. So no matter whatever the plate it is, no matter whatever the plate it is, the thickness of all the plates are going to be 25 mm. So in simple words, we take a metallic bearing plate. They are made up of metallic bearing plate, which is either square or circle, and the thickness of any plate is 25 mm. So what would be the sizes, sir? The sizes of here is nothing but for square plate, for square plate, 30 by 30 centimeters to 75 by 75 centimeters. And for circular plate, so the dimensions are going to be 30 centimeters to 75 centimeters. So in the case of the square, the width is 30 centimeters. And in the case of the circle, the dia is going to be 30 centimeters to 75 centimeters. The minimum size is nothing but 30. And the maximum is going to be 75. Okay. And you see, this 30 by 30 plate we are going to use. See, you tell me, Does gravel has a more strength, or does gravel take more load, or clay takes more load? Gravel take more pressure or clay takes more pressure? Gravel can take more pressure. You see, I apply some 100 kilopascals on two different soils. So now this is a footing. Let's say this is a gravel. Let's say this is a clay. I'm asking you, my dear, does gravel has a more bearing capacity or clay has more bearing capacity? Does gravel has more bearing capacity or clay has more bearing capacity? Obviously, gravel has a more bearing capacity. And when the bearing capacity is more, do you require less area or more area? See, what is a bearing capacity? Ultimate, whatever the load by area. So you know that the gross pressure is nothing but ultimate bearing capacity, whatever the gross load by area. You observe the load is same in the both the cases. The load is same in both the cases. I'm telling you gravel has a, so from here I can write a Q is inversely proportional to area or not. Gravel has a more bearing capacity, which means area of footing is less. Clay has a lesser bearing capacity, which means it has going to be more area. Yes or no? Yes or no? So which means in the given plate sizes, it was observed that the 30 by 30 centimeters, we use it for the gravel or dense soils. 75 by 75 clay or loose soils. Because in the case of the loose soils, bearing capacity is less. So when the bearing capacity is less, load by area. If area is more, the bearing capacity is going to be less. Okay, so now I have showed you that instead of constructing the actual footing, I am replicating this square plate or a circular plate, and the dimensions of this plates is nothing but 30 by 32, 75 by 75, and you see the thickness of any plate is simply 25 mm. Now, how the test is going to be do, sir? Let's see. How I am going to do the test is, first thing first, I am going to excavate the test procedure. I am going to excavate a trench or a pit whose width is going to be 5 times of the width of the plate. Now observe. Please observe here. Yes. So you please see, I hope it can be, this is going to be able. So first thing first, I am going to excavate a test pit. I'm going to excavate a test pit whose width is going to be, what is the width of the pit? What is the width of the pit or foundation? Whose width is equals to 5 times of the width of the plate. So where BP is nothing but width of the plate and BF is nothing but width of the foundation. Okay. So step number 1, the procedure. A trench is excavated a trial pit is excavated with a width of 5 times of width of the plate. 5 times of width of the plate. Okay. So now whatever the width of the trial pit or foundation is nothing but 5 times of the width of the plate. So BF by BP is nothing but 1 by 5. Yes. So BF by BP is nothing but the 1 by 5, whatever the area of the means width of the pit. Okay. Now, second thing, what we are going to do after excavating the pit, instead of footing, we are going to take a metallic plate and we are going to keep it at the center. You please observe, this is nothing but a plate, right? Whatever here, this is nothing but a plate. And what is the dimension of the plate? The dimension of the plate is nothing but BP. The dimension of the plate is nothing but BP. So the metallic bearing plate is placed at the center of the trench. Yes. Metallic bearing plate is placed at the center of trench. And once a trench or pit, we can call it as trench or pit. Now, while you are going to conduct the test, you have to keep one thing in your mind. BF by BP. Okay, sorry. BP by BF is equals to 1.1 by 5 or BF by BP is equals to 5. Okay. So now, while you are going to do the test, you have to check one thing. Before conducting the test, I have to check the water table level. If the water table is located at the place of the plate or above the plate, you listen. If the water table is going to be located, at the place of the plate or above the place of the plate, you have to lower down the water table by using pumping techniques. So there is a dewatering methods. You might have heard about in hydrology also the dewatering techniques. Anyways, for ESC there is a one separate topic also. We'll discuss it at the end. So by using the dewatering techniques, you are going to lower down the water table by at least 1 meter below the plate level. So which means if water table is located at plate or above the plate level, so if the water table is going to be located at or above the plate level, it should lowered by at least 1 meter below the plate level. Sir, what if the water table itself is 1 meter below the plate level, sir? Sir, initially if the water table is 1 meter below, then you don't need to do any lowering. So if the water table is yet or above the plate level, you have to lower it down to at least 1 meter below the plate level. 1 meter below the plate level. Yes, that's once you know the soil exploration, you will get to know where the water table is. You don't need to worry about that. Okay. And once you are going to place it, you please observe. What I am going to do is first I am digging a pit and then I am placing the plate. Now, you see, this is nothing but a hydraulic jack, right? You see, this is nothing but a hydraulic jack. And over this hydraulic jack, I am going to keep an I-beam. This is nothing but I-beam. And over the I-beam, I am going to apply the loads by means of a sandbag. So initially what we do is, Are Baba, this is a soil and this is some plate. And when I keep the plate, this is a plate. When I keep the plate on the soil, For getting proper contact between the soil and plate, for getting proper contact between the soil and plate, we are going to, for getting the proper contact between the soil and plate, we are going to apply a initial seating pressure of 7 kilonewton per meter square. And initial seating pressure of 7 kilopascals. So an initial seating pressure of 7 kilopascals is applied and released later. Sir, why they are applying the 7 kilopascals of a seating pressure, sir? Sir, just imagine if you keep your foot on soil, how it would be, and if you press your foot on the soil, you just keep your foot on the soil, there wouldn't be much proper contact between your feet and soil. But if you press your foot, then you can see the impression of your foot on the soil. Yes or no? The meaning of impression means there is a proper contact attained between you, means your foot and the soil. So for getting the proper contact between the plate and the soil, we are going to apply a small pressure of 7 kilopascals. Now, how the loading is going to be done? How the loading is going to be done? BF by BP is 5. Yes, I have corrected, right? BP by BF is nothing but the 1 by 5. Okay. Or you can write that also. BF by BP is equals to 5. Okay. Now, so once we apply this, now by using the sandbags, you see the mechanism. How does the mechanism look like? I apply a sandbag. This entire sandbag load is going to be taken by I-beam. And from the I-beam, the load starts to get transferred by means of hydraulic jar. And this is nothing but an extension pipe. And from here, the load is going to be acting on a plate. From here, the load is going to be acting on a plate. So loading is done by applying sandbags. Sir, how I am going to apply the sandbags, sir? And you are going to apply the sandbags at an increment level. How you are going to apply the sandbag at an increment level? The increment should not be more than 100 kilopascals, or at least 20% of the estimated safe load. Now, loading should be done by sandbags in increments as 20% of estimated load, or by not exceeding 100 kilopascals. So you are going to apply the load in such a way. One sandbag should be applied, and the next increment should be, it should not be more than 20% of the estimated load, or it should not exceed 100 kilopascals. Definitely it should not exceed 100 kilopascals. Okay. Now, listen to me carefully. Listen to me carefully. When you apply the load, definitely this plate starts to settle down or not? Don't you think the plate starts to settle down? Yes. When the plate starts to settle down, note down the settlement by using the dial gauges. So now, due to this load, the plate starts to settle down. For one increment, the plate starts to settle down, and note down the settlement at 1 minute, 5 minutes, 10 minutes, 30 minutes, 60 minutes, till the rate of settlement reaches as 0.2 mm per hour. Okay. For a particular loading, note down the settlement when rate of loading reaches 0.2 mm per hour. So whenever it reaches 0.2 mm per hour at that point of time, up to that point, you take the settlements. And finally, for that particular loading, you are going to note down the settlement by using the dial gauge. For a particular loading, note down the settlement when the rate of loading reaches, sorry, it's not rate of loading, rate of settlement. Rate of settlement reaches 0.2 mm per hour. Okay, sir, I apply sandbag, sir. As you said, the plate will settle, sir. And as the plate settle, I will measure the values from the dial gauge, sir. And the final value I will measure when the rate of settlement reaches for 1 hour 0.2 mm. So for that load, what is the maximum settlement I attained is when the rate of settlement reach 0.2 mm per hour. Okay, sir. Now I again increment the, now I again apply some more load, sir. Now I again apply some more load, sir, and I do calculate the settlement. Again and again and again by means of the increments. Now you might wonder, sir, when should I stop this test? This test should be conducted till the soil fails or till it reaches a maximum settlement of 25 mm. Test should carry out till soil gets fail or up to settlement of 25 mm. So if the soil gets failed before reaching 25 mm, then you have to stop the test. But if the soil is going to be still taking the load and reaches the 25 mm, then you stop the test. Once it reaches a total settlement of 25 mm, you stop the test. And if the soil got failed before reaching 25 mm, you stop the test eventually. For increment to increment, what is the time, sir? That's what I'm saying. Once it reaches the 0.2 mm per hour, then you have to go for the increment. So the increment should apply once the settlement reaches 0.2 mm per hour. Okay. Fails means by means of shearing only. How to say soil has failed, Ray? Sir, whenever suddenly the soil gets failed, you know that up to that point settlement is going to be there. Suddenly it pushes down. And suddenly, you know, if it is a general shear failure, you know, the soil will get slide. Plate will get slide. If it is a punching shear failure, you can see the soil failed. Yes. And once I conduct the test, I know whatever the load I have done, increments, and I'll get down the data. So whatever the data, Q and S. I start with some 50 kilopascals, next 100 kilopascals, 150 kilopascals, 200 kilopascals. Yes. So I'm going to solve all these things. As simple as that. Test should carry out till the soil gets failed or up to settlement of 25 mm and note down the corresponding load and settlement. For one particular loading, when you are going to find out the settlement, whenever the rate of settlement reaches 0.2 mm per hour, then you increase the load. So BF by BP is equals to 5. No, sir. Yes, that's what. Why you are asking till? Sir, why 25 mm only? Very good question. Are Baba, if this is a ground level, what is the thickness of the plate? This is BP. What is the thickness of the plate? The thickness of the plate is 25 mm. Yes. So you are going to conduct this test till the entire plate is going to be goes beneath the pit level till the entire plate is going to be goes beneath the pit level. Okay, so the plate is going to be pushed and pushed and pushed in such a way. If the plate is going to be goes beneath the trench level, then you are going to stop the test. Why? Because why 25 mm? Because the thickness of the plate is 25 mm. So that is the reason why we stop the test there. So once we got this, what we do is we are going to plot the graph. We are going to plot the graph, and that graph goes as okay. So in x-axis Q, in y-axis, yes, settlement. So Q versus settlement. Now you know that when the failure is going to be happen, in the case of the shallow foundations, there are two type of failures: general shear failure. Yes or no? I hope while I was discussing the general shear failure and local shear failure, while I was discussing about the general shear failure and local shear failure, okay, so I told you the failure varies, how it is going to be there. So if the failure means after drawing this one, if I got to know the soil fails like this, then what type of failure it is? If the soil means eventually, I told you test should carry out till the soil get failed or up to 25 mm settlement. If it is a general shear failure, you know the soil fails suddenly. Yes, and this is nothing but the general shear failure. And at a failure, whatever the load you are going to see, this is nothing but the ultimate bearing capacity. And whatever the settlement you see, this is nothing but the maximum settlement. So what is meant by safe settlement then? Any settlement value less than S maximum, that is going to be the safe. So once I draw the graph, if I get the graph in this way, that's nothing but general shear failure. That's nothing but general shear failure. Okay. So now, sir, if the graph, for example, I'm going to draw the graph, sir. Now again, if I draw the graph, so if I draw the graph, let's say Q again, yes. Now, if I draw this graph, let's say if the graphs comes in this fashion, there is no failure. I am not seeing a failure point and I am going up to settlement of 25 mm. Then what type of this failure? This is nothing but local shear failure, right? Sir, in this local shear failure, I am not able to get the failure load, na sir. What to do, sir? See, this is a normal graph. This is a normal graph. When I draw this one, so if the curve goes like this, can you see anywhere failure point? You can see this is nothing but a failure over here. Yes. You can simply say this is nothing but a failure point. So you know that general shear failure is a well-defined failure, but local shear failure is not well-defined. Now, how to find out the failure load for this? For that, we have a method known as a tangent. What we do is, we just draw a tangent, initial tangent. When the curve has started, you draw the initial tangent, and at end point, you draw the final tangent. And wherever they are going to be meet, and this point, this is nothing but the failure point, and this load we call, whatever the load that comes up here, we call this one as a ultimate load carrying capacity. So in the case of the local shear failure, what I got to know here is I have two ways. One thing is for sure, either by means of drawing or the ultimate load is going to be attained by drawing initial and tangents to initial and final points, or the pressure QU is equals to pressure at a settlement is 1/6 of BP. Okay. So whatever the ultimate load carrying capacity, either you draw by means of a tangents for the initial point and final point, or whatever the load corresponding to settlement as, BP by 6. Whatever the load corresponding to settlement as BP by 6. Okay. Sir, and in the case of LSF, there is one more way also. What I do is, in the case of LSF, there is one more way. The other way is, we plot the graph in a log scale. We plot the graph in a log scale. We plot the graph in a log scale. So for this one, this is also going to be the LSF one. So when you plot the graph, see, sir, how tangent intersect decide failing point. That's what I'm showing. That's what I'm going to do. You please observe why this is not. This is an approximate way. That's the reason why what we do is so we are going to plot in log scale. When you plot in a log scale, now the graph is going to be looks like. You see, this is how the graph is going to be looks like. Now this is nothing but failure. Wherever there is a sudden change in the curve, you see sudden sharpness. Now this is nothing but the failure point. So in log scale, QU can be obtained directly. In log scale, QU can be obtained directly. Okay. So first thing first, in the case of the general shear failure, I don't have any problem. So directly I apply the load, I find out the settlement, there is a failure. But in the case of the local shear failure, if you go with a normal graph Q and S, QU obtained by drawing tangents to initial and final points, and QU is equals to Q at the rate of settlement, settlement as 1/6 of width of the plate. But if you go with log scale, then you don't need to worry about any tangent or BP by 6. You can directly find out by looking the failure point. Okay. This is the process of the plate load test. I hope you understood. But here, there's one big confusion. What is that, sir? Hey, Baba, whatever the test are we conducting on plate or foundation? Think and say. Whatever the test we are conducting, are we conducting on plate or actual foundation? We are conducting means we are getting the ultimate load carrying capacity and settlements. Obviously, we are getting ultimate load carrying capacity and settlements, but we are getting under plate. But what we require is under the footing. What we require is under the footing. Yes. So now the biggest limitation that comes is the QU and settlements we obtained is for the plate, not for the footing. Are sir, then what may happen, sir? Sir, you see the limitations. Observe. For example, yes, this is a plate of width, and this is a foundation, actual foundation. Okay, so this is a plate, and this is actual footing. Actual footing. Yeah. So now you please observe, for the same load applied on both, whatever the pressure I am applying Q on both the footing and plate. So that's going to be there. But what is the width over here? BP. What is the width over here? BF. That's actual footing. Now, if you observe, I hope you remember the pressure bulb concept. Did you? Chapter number 7. I told you whatever the load you apply, the significance of that load will be inside of the pressure bulb. Remember the pressure bulb, right? So now if I draw the pressure bulb for the plate, the pressure bulb is going to be small. But for the footing, the pressure bulb is going to be looks like this. Yes or no? So now if you observe, this is going to be the pressure bulb. So actually, if you ask me, in the case of the plate, the width is going to be less, so its pressure bulb is going to be small. But in the case of the actual footing, the soil under which the entire means the load which is having under influence more soil, right? More the soil is under compression, more settlement. More the soil is under compression, more settlement. And I told you clearly the depth of the pressure bulb. I hope you remember. So whatever this depth, I gave you this depth as significant depth or depth of exploration. So significant depth. Yes. And in this case, the significant depth is nothing but 1.5 to 2 times of width of the plate. I hope you remember. For square plate, 1.5 to 2 times of BP. For a strip, 2.5 to 3. I told you that point also. So for square plate, 1.5 to 2 times of BP. For a strip, 2.5 to 3. Similarly, here also, what is the significant depth here? This is 1.5 to 2 times of width of actual foundation. So point number 1, the difference over here is, point number 1, the difference over here is whatever the QU limitation, whatever the QU and S are obtained on plate but not on actual footing. Are obtained on plate but not on footing. So I can say more the width of footing, more the pressure bulb, and more the pressure bulb, obviously more settlement. More the pressure bulb, more settlement. And bearing capacity. You remember the Terzaghis ultimate bearing capacity, right? I told you in the case of the Terzaghis ultimate bearing capacity, there are 3 effects: cohesion effect, depth effect, and width effect. Remember the width effect? Yes or no? So if the width changes, the ultimate bearing capacity is also going to be changes. So whatever the values I am getting from these graphs are not true. They are under the plate. So now I have to do correction. This is the biggest limitation. So corrections to be done for the ultimate bearing capacity and settlement. Corrections to be done for the ultimate bearing capacity and settlement. And second one is, Baba, Is this test is a short-term loading test or long loading test? It's a short-term duration test or long duration test? Can you please tell me, is it a short duration test or long duration test? Very good. Short-term duration test. When it is a short-term duration test, in the case of clays, does the settlement takes immediately or the settlement takes a long time? So I told you in consolidation, there are two settlements, immediate settlement and primary consolidation settlement. Immediate settlement and primary consolidation settlement. Are Baba, when you apply the load, before the pore water dissipate, whatever the settlement is immediate settlement. Once the pore water starts to dissipate, then the settlement is primary settlement. Now, this test is a short-term duration test, which means whatever the settlements we get is immediate settlement. So you tell me, does this test is going to be more suitable for the clay soils? No, this test is not appropriate for the clay soils. Okay, so this is a short duration test, and settlements obtained are immediate settlement. Settlements obtained are the immediate settlements. Not suitable for clays, as primary consolidation settlement takes more time. And see, in the reality, we don't lower down the water table up to the 1 meter below the footing level, because I told you if water table is anywhere, we can construct the footing. But if the water table is above the base of footing, ultimate bearing capacity will decrease. So here one more limitation is lowering of water table. So that's the limitations. First thing is QU and S are obtained on the plate but not on the footing. So now let's see how we are going to attain the ultimate bearing capacity and settlements of actual things. So now let's see the corrections. This is important. So far and so good, whatever the discussion I made, this is the critical and for conceptual points in ESC. Now, what are the questions that you can get over here is, sir, what about PSF? PSF occurs in pile foundations, na? I told you shallow foundations, we see GSF and LSF. PSF can be seen in the deep foundations, okay? I mean, pile foundations. So now, corrections. First one. Settlement correction. So settlement correction, okay. And if it is a clayey soil, I hope just now I mentioned the immediate settlement, right? I hope you remember the immediate settlement equation. If you do remember the immediate settlement equation, the net pressure by Young's modulus into B into 1 minus mu square into I. I hope remember this equation. Whatever the net pressure means the pressure from the external load, pressure from the structure by neglecting the self weight of the soil mass. Okay, so from here I can simply write SI is directly proportional to B. This is for clays. In the case of the clays, so the ultimate settlement means the immediate settlement is directly proportional to the width. Hope you remember this equation. And if that is the case, now from here I can write The settlement is directly proportional to the width. So I know the width of the footing, the width of the foundation, then SF by SP is equals to BF by BP. So simple, right? You don't need to remember here. Do I need to? No. Now, if it is a sandy soil, in the case of the sands, the equation doesn't valid. In the case of the sands, here SF by SP is equals to BF by BP into BP plus 0.3 by BF plus 0.3 whole square. So BF by BP into BP plus 0.3 by BF plus 0.3 whole square. Okay, so this is a settlement correction. In the case of the clays, the settlement is S directly proportional to B, but in sands, SF by SP is equals to BF by BP into BP plus 0.3 by BF plus 0.3 whole square. Hope you understood. Next, second one, bearing capacity correction. Bearing capacity correction. Okay. So what is this bearing capacity correction? You please observe, while I was doing a test in a test pit, okay, so this is a plate. Now, from the Terzaghi, what is ultimate bearing capacity? As it is a square plate, na? From the Terzaghi, what is the ultimate bearing capacity? 1.3 CNC plus gamma D NQ plus 0.4 gamma B N gamma. Yes or no? Okay. Baba, here I am applying this load Q. Is there any surcharge acting over here? Please tell me. Is there any surcharge acting over here? So next to the sides of the plate, is there any surcharge acting over here? I want you to answer. Is there any surcharge acting over here? Here. What is the mean by surcharge? You know that whatever the soil above the base of footing or above the base of plate, there is no soil here. As there is no soil, there is no surcharge. When there is no surcharge, I can eliminate this term 0. Now, if it is a clay soil, you know N gamma is also going to be 0. Yes or no? If it is a clay soil, you know that N gamma is equals to 0. And what is QU? The QU is equals to 1.3 CNC. Have you remembered a point? The ultimate bearing capacity of a clay soil is independent on width of footing. Remember that point? And if it is a sandy soil, you know that C is equals to 0. Then QU is equals to 0.4 gamma B and gamma. And I can write over here QU is directly proportional to width. Yes. Sir, why you have discussed this thing now, sir? Because you know that when the width changes, just now I mentioned, when width changes, ultimate bearing capacity also changes. How? In clays now. In clays, come on, tell me. QU is independent on width, as simple as that. So whatever the ultimate bearing capacity in the case of the foundation is equals to simply plate. So whatever the ultimate bearing capacity I got on 70 centimeters by 70 centimeters plate is equals to 7 meters by 7 meters foundation also. Because in the case of clays, the ultimate bearing capacity is independent on the width. Whereas in the case of sands, just now I mentioned, right? QU is directly proportional to width. So whatever the bearing capacity under footing is it by plate is equals to BF by BP. With the reasons, I have mentioned all these things. With the reasons also I have written. So if you observe, yeah, bearing capacity correction. So in the case of the class, you know, N gamma is equals to 0 and QU is independent on width. And in the case of the sands, C0, so they Q directly proportional to width. Hope you understood. Yeah. Okay. So yes, so that's all about the plate load test. We have seen a lot of things regarding to the plate load test. Give me a minute. Okay. So now let's see. The units used are meter only. It's up to you. If they give in meters, I mean maximum we use in meters only. Now let's see a question based on this. Yeah. You see the second question. In a load test means plate load test conducted at a depth of 1 meter below the ground. In a load test conducted at a depth of 1 meter below the ground with a square plate. So given is a square plate of 30 centimeters. So square plate and width is 30 centimeters on a granular soil means sand. Okay. Load required to cause a settlement 25 mm was a 7.2 tons. What is the load required to cause a 7.2 tons is nothing but 25 mm settlement. So whatever the load required is nothing but 7.2 tons to attain a settlement of 25 mm. Okay. If the settlement is limited to 10 mm, the allowable bearing pressure will be. If the settlement is limited to 10 mm, then what is the allowable pressure? See, if you observe, you know that as a load acting on the soil increases, settlement is going to be increased. So you know that Q is going to be directly proportional to S. Whatever the settlement are, I can say the settlement is directly proportional to the settlement is going to be directly proportional to the pressure you apply. So first for the Q1, what is that is a load, right? I have to convert into pressure. They're asking bearing pressure. You see, they're asking bearing pressure. Then what is Q1? Area 7.2 by area 0.3 into 0.3. So what is this value, Q1 value? What is this Q1 value? 7.2 by 0.3 into 0.3, which comes as 80 kilopascals, which means if you apply a load of 80 kilopascals, the soil got settled to 25 mm. Now, if you wish to limit to 10 mm only, how much allowable pressure should be there? That's what. So S direct proportional to Q, S2 by S1 is equals to Q2 by Q1. As simple as that. So I want Q2, right? Q2 is equals to S2 10 mm by 25 mm into 80. Tell me the Q2 value. So which comes as 32 ton per meter square. Which comes as 32 ton per meter square. Very simple. See, here the point is like as load increases, settlement is going to be increases. That's it. Okay. Next. That's all about 8 questions. I mean, so classroom practice questions. See some of the previous GATE and ESC questions. Yeah. You see this question, this was ESC question. And first I want to go with this one. Yeah. So in a plate load test on a sandy soil, the test plate of 60 centimeters by 60 centimeters undergoes a settlement of 5 mm. So what is the test plate? 60 by 60. And the soil is a sandy soil. Soil is sand. And width of the plate is going to be 60 centimeters, which I can take it as 0.6 meters. First, I'll write everything in terms of meters. And eventually, so whatever this one, now BP is equals to 0.6 meters. Now, eventually, undergoes a settlement of 5 mm. So what is the settlement of a plate here? 5 mm. Whatever the pressure is 12 into 10 to the power of 4 Newton per meter square. What will be expected settlement of 3 meter by 3 meter under same pressure? So if I apply the same pressure on a footing whose width is going to be 3 meters, then what is a settlement? The settlement of the footing, how much it is? How much the settlement is? So you know that in the case of the sands, SF by SP is equals to BF by BP into BP plus 0.3 by BF plus 0.3 whole square. Yes. So if you solve this, then SF by SP. What is SP? 5 mm. See, now I'm not converting this one, because if I keep SF means SP 5 mm, whatever the solution I am going to obtain is also going to be 5 mm. Why? On the RHS I am using in terms of meters only. is equals to BF 3 by 0.6 into 3 plus 0.6 plus 0 plus 0.3 by 3 plus 0.3 whole square. So SF by 5 is equals to, I don't have a calculator, let's try to solve. 0.6 by 0.6 plus 0.3, 0.9. 0.9 by 3.3. 0.9 by 3.3. 3 by 0.6 into 0.9 by 3.3. Okay. And this is going to be whole square. And what we can write here is 1.1, 0.3 and 0.2. Yes, can I write like this? So 0.3 by 0.2, 3 by 2, and SF by 5 is equals to 0.3 by 0.2, 3 by 2, 1.5 by 1.1 whole square. 1.5 by 1.1 whole square. See, 1.5 by 1.1. See, what is 1.5 square, my dear? 15 square. 15 square, 225, right? So 225, like if I solve this one, 15 square is going to be 225, which is nothing but 2.25. 2.25 into 5. 2.25 into 5. 2 into 5, 10. So answer should be more than 10. It's not going to be 9. It's not going to be 9. So if you solve, what should be the answer? Come on, tell me. What is the answer? Okay, sorry. It should be less than 1.5 by 1.1 square into. So answer should be, like, if you solve, it's going to be 9.29 mm. 9.29 mm. So in previous question, in case of granular soils, Q versus S is not straight, then how can we simply Q is directly proportional to? We have to take, there is no peculiar relationship between the settlement and discharge. Load. So we assume when they don't give the variation, we have to assume it as linear. We are assuming it as a linear. Okay. Now, so the nearest answer is going to be 9 mm. The nearest answer is going to be 9 mm. Okay. Yeah. So one of our student is asking me, sir, what if the footing pressure is not going to be same? Now, you see this question. You observe. In this question, I have done 60 by 60 and I got the expected settlement as this much. And I am applying same pressure. Now you see this question first thing first. Understand this question? Understand this question? Yeah, here the Q values need not be you use, because under same pressure they mentioned you don't need to use any Q value. If you ask me, while I was explaining the same thing, so here the same pressure I applied. For the same pressure, more the width of footing, more pressure bulk, more settlement. Come on, tell me. A strip footing, so which is going to be 8 meter wide. A strip footing, which is 8 meter wide, is designed for a total settlement of 40 mm. Is designed for a total settlement of 40 mm. Okay. Now, whatever the strip footing, that is designed for a total settlement of 40 mm. The safe bearing capacity was 150 and the safe allowable pressure was 100. I hope you remember the allowable pressure. Net allowable pressure, I told you. This is nothing but safe allowable pressure. What is mean by allowable pressure? What is mean by allowable pressure? Think and say. What is mean by allowable pressure? Allowable pressure, the pressure at which soil can take safely without any shear and without any excessive settlement. This is what I mentioned. But Papa, here the soil is going to be shear at 150, but you see the allowable pressure, it should be smaller of QS and QP, right? So what is this QS? Safe bearing capacity. And this is nothing but safe settlement pressure. Okay. So now in this question, you tell me whatever the QS I have given as 150, that's a safe bearing capacity, 150 kilopascals. But what is QA? QA is 100 only. Then can you please tell me this QA is either QS or QP? Come on, tell me. So whatever the safe pressure that the soil can take, means whatever the gross pressure that the soil can take without any excessive settlement is nothing but QP. And in the given question, see, generally QNA, net allowable is nothing but net safe and net safe settlement pressure. Now I am saying allowable, which means gross, na? So the allowable pressure is nothing but the gross pressure Q that a soil can bear safely without any shear failure and without any safe settlement. Can you please tell me what is this QA now? Think and say, does QA is QS or QP? Does QA is QS or QP? As QA is less than QS, then given QA is equals to safe settlement pressure is equals to 100 kilopascals. This is the meaning. Okay. So what is the gross pressure that a soil can take without any excessive settlement is nothing but 100 kilopascals. Now, if I apply 100 kilopascals on a strip footing of width 8 meters, what is the settlement I obtained is 40 mm. What is the settlement I obtained is 40 mm. Okay. Yes. So now, whatever the QP is nothing but load by area of footing. How much it is? 100 kilopascals. Okay. So at what load it is going to be obtained 40 mm? For this 8 meters, at what load it is going to be obtained? For 8 meters width, that settlement is going to be 40 mm. So for that load, 8 meters, which is nothing but 8 into 1. It's nothing but strip, right? 100. So what is that load? I applied 800 kilopascals. Sorry. I applied 800 kilonewtons. The load I applied is going to be 800 kilonewtons. For load of 800 kilonewtons on 8 meter strip footing. On 8 meter strip footing, the settlement pressure is going to be 100 kilopascals, and the settlement I obtained, how much? 40 mm. This is the meaning. I am not going through the full question also. What I am saying is, up to this point, you observe there is a strip footing. On that strip footing, you apply some gross pressure. So the allowable soil pressure is 100, which means the maximum pressure the soil can take safely is 100. That's nothing but safe settlement pressure. So for that, what is the load I applied? 800. On that footing, 8 meters, then the settlement is going to be 40 mm. Now, due to importance of the structure, now the footing to be redesigned for total settlement of 25 mm only. Now, you see, due to importance of the structure, the footing is to be redesigned for total settlement 25 mm. Then what is the new width of the footing? You know that if width changes, bearing capacity also changes or not? Yes. You know that as I change the width, As I change the width, then the settlements are going to be changes. As I change the width, then the settlements are also going to be changes, and bearing capacity is also going to be changes. Yes or no? So now what I want here is, if I want to reduce to settlement of 25 mm, what is the new width? Hey Baba, for settlement of 40, the pressure is 100, then the width is 8 meters. I am not going to change the load. You please observe, whatever the load 800 is coming from whom? Same structure. So as a structure is same load of 800 kilonewtons pass through footing. Okay. So, but if that 800 passes through 8 meter strip footing, I got the pressure of 100 and settlement of 40. Now, you know, for settlement of 40 mm, the pressure was 100 kilopascals. But I want to settle to 25 mm. What is the pressure? Similar to the previous question, whatever the question I have mentioned here, you please observe. So here also same thing, but here I kept a plate constant, but here I am saying the load constant. Okay. So now can you please tell me here? Yes. Now, yes, directly proportional to Q. So Q2 by Q1 100 is equals to S2 25 by 40. So from here, what is a Q2? Listen to me carefully. Are Baba, if the safe settlement pressure is 100, then the footing can undergo up to 40 mm. The more the bearing pressure, the more the settlement we can take. But now I'm limiting to only 25 mm. So if I do limit, then what is the allowable pressure? It should be 62.5 only. Now the load is same 800. I got to know this is 62.5. Then what is the width? This Q2 is equals to Q by B2 into 1, which is equals to 62.5. So 800 by 62.5. Then what is the B2 value? Come on, tell me. So this is going to be 12.8 meters. Whatever the width we obtain, that's nothing but 12.8 meters. What about Q-safe? You don't need to worry. See, here they have given the Q-safe to confuse you. They gave Q-safe. If they would not given this one, then I don't need to bother about it all. But they have mentioned the allowable soil pressure. So out of these two, which one I have to take? Out of these two, I have to take allowable only, right? Whatever the settlements we are calculating is for allowable. So we don't take 150. We are discussing about the safe settlement pressure. We are discussing about settlements, not on the shear cases. So these type of questions you can expect from the plate load test. Okay. Now, there is a one more approach. Okay, not approach. So far and so good. You are seeing that RSR permissible settlement. You are saying the settlement should not be more than this one and that one. Yes. What should be that value, sir? Let's come to the values of these permissible settlements. So how do you know that is a granular soil? I did not use any granular soil. See, whether the soil is granular or clay, I don't care. But the settlement is directly proportional to Q. Settlement is directly proportional to Q. Because as I did not mention anything regarding to variation of settlement over pressure, I know settlement increases with respect to pressure, so I took S directly proportional to Q. Generally, whether it is a granular soil or clayey soil. So settlement is directly proportional to width. Can we use that? No, you cannot use that. You cannot use that. Why? If you ask me, look, listen to me carefully. Why I used this equation? Because the pressure is same. But you tell me in this question, do you think the pressure is going to be same? No, the pressure is not going to be same. Here the pressure is not going to be same. See, in this question, I'm comparing the plate and the footing. And in this question, I am taking only the plate. Means in this question, I'm going to take only the footing. Under footing, on that footing, if you apply load, as the load increases, settlement is going to be increases. As the load decreases, means as the pressure decreases, settlement is going to be decreases. Okay. Now come to the permissible settlements. Permissible settlement. So what is mean by this permissible settlement, sir? Permissible settlement means the maximum settlement that a structure can be allowed without any excess, or the settlement up to which the structure can be allowed. Up to which the structure can be allowed. Okay. So there are two types of settlements. One is differential settlement and the other one is allowable settlement. So differential settlement, you know that. What is the meaning of differential settlement? What is the meaning of differential settlement? What is the meaning of differential settlement? The meaning of differential settlement is the difference in the footing levels. That difference in the footing levels. Yes or no? So you know that if one footing settles more than the other footing, if one footing settles more than the other footing, we call it as a differential settlement. And in this differential settlement, if it is a sand and if it is a clay, so in the case of the sands, maximum that you can allow is 25 mm only. The permissible means up to that point, settlements up to which structures can be allowed. So in the case of the sand, you can allow the difference between the footings up to 25 mm, which is 2.5 centimeter. This inch, you can see the inch. 1 inch is nothing but 2.54 centimeter or 25.4 mm. So this much amount of the settlement that you can allow between our two footings when you construct on a sandy soil. And you tell me, does a clay soil has more or not? What, Mr. Kumar Vishwateja, what you need to remember? Okay. So now you tell me, in the case of the clays, normally the clay is more compressible soil. Yes or no? As you know, the clay is more compressible soil, then you should take more permissible value or less permissible value. Obviously, you have to take more permissible value for clays than sands. So in the case of the clays, already you know clay is more compressible. So there is a possibility in clays more differential settlement will take. But what is the maximum settlement that you can allow is 40 mm only. So in the case of the clays, you can allow the differential settlement up to 40 mm. And if this is going to be exceeds more than 40, if this is going to be exceeds more than 40, then we are going to say it as a excessive settlement and allowable settlement. Under footing. So differential settlement means between two footings. Allowable settlement means under a single footing, what is the maximum settlement that you can allow? Soil isolated footing raft foundation or footing. Okay. So if the soil is a sand or hard clay, and if the soil is going to be soft clay. If the soil is sand or hard clay, and if the soil is going to be hard clay, soft clay. Now, in this case, can you please tell me, question number 1 for you, does the footings of isolated means does isolated footings undergo more settlement or raft footings undergoes more settlement? Think and say. Does isolated footing will undergo more settlement or raft footing will undergo more settlement? Wow, isolated, raft. Baba, just now I mentioned that you see this and tell me more the width of the footing, more the pressure bulb, more the settlement. Yes or no? See, in the case of raft foundation, width is more. Isolated foundation, width is less. Obviously, the raft foundation undergoes more settlement. But then why we are preferring the raft foundation, you may ask me. The point in the case of the raft foundation is, in isolated foundation, though the settlement is less, but it will cause a differential settlement. Differential settlement is much more vulnerable than the direct settlement. If there is a differential settlement, the structure may get some cracks. I showed you the figure also. So in the case of the raft foundation, you know that more the width of the footing, more the settlement. More the width of the footing, more the settlement. Yes. Okay. So I can say the raft footing undergoes more direct settlement. It prevents differential settlements. Okay. So though the raft footing undergoes more direct settlement, it prevents a differential settlement. It prevents the differential settlement. Okay. So that is the biggest advantage. Now with this concept, can you tell me, with this concept, can you tell me in which case the permissible value is going to be more? In which case the permissible value is going to be more? Obviously, raft undergoes more direct settlement, so more permissible value should be for the raft. If you see, this is going to be 50 mm, and in the case of the raft, you can allow up to 75 mm also. Doesn't matter. And in the case of soft clay, you know, soft clay undergoes more settlement. So compared to sand or hard clay, in soft clay, it can undergo up to 75 mm. And if it is a raft, it can undergo up to 100 mm. Which means if you construct a raft foundation on the soft clay, the maximum settlement that you can allow is 100 mm, 10 centimeters. Hope you understood these values. That's all about the shallow foundations. That's it. We'll solve some previous GATE and DSC questions. That's it. Yes. Combined footing. Yeah. What is meant by combined footing? Combined footing, you know, right? Combined footing, if you combine two or more columns, then you can get the combined footing. Not a problem in that. Okay, so now let's see. Okay. So that's it completed. This is some of the previous GATE and ESC questions. So what if the footing is non-prismatic, Mr. Mohammed? That's a good question. The non-prismatic is nothing but trapezoidal footing. You don't need to worry, because whatever the load that comes, if it is going to be something like here, this is one footing, I mean this is one column. Okay. So whatever the load over here below, the reaction is going to be same, na? Below the reaction is going to be same. See, I'll write this one in this fashion. You please observe. Q1, Q2. For this Q1 and for this Q2, what I'll do is I'll find out the reaction. And whatever the ultimate bearing capacity or allowable bearing pressure for the soil is nothing but reaction by area of footing. That's it. See, what is allowable bearing pressure? The pressure that the soil can bear without any failure, whether it is a shear failure or settlement pressure. So it is upward in direction. It is upward in direction. And the upward in direction is nothing but upward reaction by area of footing. Whatever tapered is nothing but trapezoidal only. We discussed about rectangle, square. Now it's a tapered trapezoidal. So what about offline classes? That I have to Mr. Sumant Reddy. The Telangana High Court has given stay for 7 days. That I haven't gone through the news yet. I was busy with some other things. So let me see that and let me know you after the break. I'll let you know regarding to that. Now let's have some questions, please. Previous GATE and ESC questions. Okay. So now let's see these questions. Yeah. So the ultimate bearing capacity of a surface strip. See, I'm asking you the ultimate bearing capacity of a surface strip footing. What is the meaning of surface strip footing? What is the meaning of a surface strip footing? The footing is located on the ground surface. So this is the ground level. If I say ground level, then D is equals to 0. Depth of the footing is going to be 0. And as I mentioned, this is a clay soil. In the clay soil, NC 5 point, as per Terzaghi, right? 5.7. It's nothing but Terzaghi. And NQ is equals to 1 and N gamma is equals to 0. So you know the ultimate bearing capacity, and that's a strip footing, CNC plus gamma DNQ plus 0.5 gamma B N gamma. Yes. As it is a clay, N gamma 0, surface D0. What is QU? 5.7 times of C. I mean, for the explanation for you, I am writing all these things, but if you ask me, I can directly say surface, depth effect gone, clay, width effect gone. What else remaining? Cohesion effect. That cohesion effect, is it strip? If it is it a strip? Yes. 5.7 into C. If I would have given base is smooth, if I would have given base is smooth, then 5.7. Sorry, base is smooth means 5.14 C. Okay. So can we call which has moved to column select as mat foundation? No, my dear. Yeah. So now this is one of the beautiful question. It was asked in long back 1996, but I feel like out of all the questions that appeared, especially in 2 marks, so these are one of the beautiful question. How? Now, for a strip footing, now it gives the type of failure we remember. If you remember, on a saturated clay, so the given is a clay soil, phi u is equals to 0, and the failure is semicircular failure surface, which means circular arc. You remember in chapter number 15, stability of slopes, the failure is going to be happen as a circular arc. Yes or no? So here, the shearing is going to be happen in a circular arc. And if that is a shearing, then there must be resistance acting along here. Yes, there is a resisting force. And due to this load, it is going to be undergo shearing or not. Now, when it is undergoing shearing, it must take place with respect to one point. Yes or no? Now, you please observe. You know, this entire load I can represent as some point load. Can I write that? I can represent this ultimate bearing capacity as some point load. What is that point load? I can write as some ultimate load. Now, the same thing I can replicate as this is a ground level, and this is a load QU, and this is a point. So let's take this as a point C, because with respect to one point, I have to take the moments, right? Whenever there is a circular failure, should I take a moments or should I take forces? When the soil fails by circular, which means there is a rotation. The rotation is going to be happen with respect to some point, right? Let me take that point as C, which is nothing but center. From this center, anywhere you take, the radius is going to be C. So let's take this as a point C. Okay. And what about this value? This value is going to be B by 2. Now, semicircle, I mentioned. Have I mentioned that point or not? Semicircle. And you remember, whenever I take the slip surface, in chapter number 15, I told you, assume the trial slip surface circular arc and rotation occurs with respect to center. Now, what is the center here? See, you know, the total width from here to here is 2b. and at center it is going to be B. Now, who is going to be cause a momentum? Who is going to be cause moment over here? Who is going to be cause the moment? The load acting on the ground level is going to be act of footing. That means is going to be cause the rotation, and the resistance, whatever the resisting force F R, you take from the center anywhere, it's nothing but radius. And what is this radius? The diameter is to be, the radius is simply B. So now first thing first, the driving moment is equals to the ultimate load into B by 2. The driving moment is equals to ultimate load into B by 2. Okay. And what is the resisting moment? The resisting moment is nothing but resisting force into R, which is nothing but B. But what is resisting moment? Shear strength into length of arc into B. Yes. Yes or no? Now the point is, the soil is nothing but phi u is equals to 0 degrees. As a soil is a Cu is, as a soil is equals to, you know that S is nothing but Cu plus sigma into tan phi u. But anyways, I am taking phi u 0, then S is equals to Cu. And can you please tell me what is length of arc over here? Arre Baba, the length of arc is nothing but perimeter, right? The length of arc is nothing but, it's nothing but semicircle, na? This is a semicircle. And what is this length of arc, please? What is the length of arc? A semicircle means what is angle? 180 degrees. Yes. For 2 pi, perimeter is 2 pi r. For pi, what is the perimeter? Pi r. Yes. So, for 2 pi angle, the perimeter is 2 pi r. For pi, which is nothing but semicircle, what is the perimeter? Pi r. So which means the length of arc is nothing but pi r. Yes. Yes or no? And what is that r in the given question? In the given question, the r is nothing but B. So in simple, I am going to take for a given failure surface the bearing capacity equation I want. I want to find out the QU. What is the bearing capacity equation? That's what I require. Yes. So now, if you observe, what is this QU? QU, the load into whatever the load into its lever arm is nothing but B by 2. Taking moment about C. Taking moment about center C. Okay. So now you see, if I take this moment about center C, okay, simply failure, there is a resisting, there is a causing. That's the principle that I applied in the entire chapter number 15. I need to know who is resistance, who is causing. So who is causing here? Whatever the load due to the structure. So now from here, yet a failure, the resisting moment is equals to the driving moment, or driving moment is equals to the resisting moment. So what is our driving moment? QU into B by 2. What is the resisting moment? SC into lever arm, means LR into R. Yes. Now, what is the ultimate load? Baba, if you know the pressure, how to find out the area? So this is a strip footing, right? Pressure is nothing but load by area. Pressure is nothing but load by area. QU is nothing but whatever the load by area. Strip footing B into 1. So I can write QU as small QU into B by 2 is equals to, what is the shear strength? Cu into, what is the length of arc? Pi B into, what is the radius? B. Now BB will get cancelled. What is the ultimate bearing capacity? 2 pi Cu. That's how we are going to get it done. I already told you I don't discuss about the same questions in previous gate and ESC. I want you to look over the other dimensions also. You observe, now I hope you got this. The same way the Terzaghi also done. The same way Terzaghi also done. So the Terzaghi assumed if this is a footing, Terzaghi has given, right? How the Terzaghi failure has been. In the case of Terzaghi, the failure, elastic zone, radial shear zone, and then there is a passive zone. Yes or no? So here this is nothing but the failure and there is a resistance. So by taking these only, this is moments over here. So because there is a translation and there is a rotation, both are there. In the case of the Terzaghi, according to Terzaghi, there is a translation. This is nothing but translation. And here there is a rotation. Both you have to take. That's highly complex in nature. So for everything you have to take the driving and the resisting. From here only he got, the Terzaghi got QU is equals to CNC plus gamma DNQ plus 0.5 gamma N gamma. That's a failure, different failure. But whatever the given question I mentioned, this is a circular, semicircular. I can do it directly. So what is the answer? The answer is 2 pi Cu. Answer is okay. So hope you understood this. Yeah. Now you see this question. The width and the depth of a footing are 2 meters. What is the width of the footing? 2 meters. What is the depth of the footing? 1.5 meter. Water table at a site is at a depth of 3 meters below the ground level. Array, if this is a footing, you know this is D 1.5 meter. And you know this is B is equals to 2 meters. Which means the total depth from the top to bottom is 3.5 meter. Yes. Okay. Now the water table at a site is at a depth of 3 meters below the ground level. So water table at a site is 3 meters below the ground level. This is 3 meters. Okay. Now, what is the water table correction factor for the calculation of the bearing capacity? What is the water table correction factor for the calculation of the bearing capacity? I want to find out what is a water table correction factor. See, in the above the footing, is there any water table correction? No. Above the footing, is there any water table correction? No need of any correction, right? But below the footing, I need to do the water table correction. So now can you please tell me what is ZW? What is this ZW? Are 3 meters na? So if this is 1.5, then the ZW is also going to be 1.5. Yes or no? I told you clearly. So ZW1 is maximum of D only. That I cannot do anything. What is ZW1? It's simply 1. I don't need to do any correction. But as a water table is lying below the ground level, means below the base of footing, you know the water table correction factor is nothing but 0.5 into 1 plus ZW2 by B. Have you remembered this? If you have remembered, I hope you got to know what is mean by ZW2. What is the total depth of water from ground level? 3 meters. Out of that, above footing 1.4, below footing 1.4. So 0.5 into 1 plus 1.5 by 2. You have a calculator, right? 1.5 by 2, which is nothing but 0.75. 1.75 into 0.5 comes as 0.875. 0.875. Okay. Sir, Naidu, sir, how can get idea about previous question that way only the solve? See, it's about understanding when there is a failure, they're asking failure. Whenever I mention failure in the stability of slopes, failure, 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 you look who is resisting, you look who is causing. If you understand that, then you will get the answer. Okay. So now let's solve this question. This is also one of the very good question. Whatever the questions that came out of scope, so that you can understand more. That's the reason why I am discussing these questions. Remaining questions, you can solve it. Now you see this question. Four columns of a building are to be located within a plot size of 10 meters by 10 meters. So what is the plot size? This is a plot size. The total plot size is 10 meters by 10 meters. Okay. Now, the expected load on each column is going to be 4,000 kilonewtons. So how many columns are there? 4 columns are there. So if I take 4 columns and each column has a load of 4,000, the allowable bearing capacity of the soil is just 100 only. If the allowable bearing capacity is 100, then what is the type of foundation best suited? So should I go for isolated, or should I go for raft, or should I go for pile, or should I go for combined? So here I have to go for trial and error procedure. Here I have to go for trial and error procedure. How now? You see. First of all, if I assume it as isolated footing, for isolated footing, which means for one column, one footing. For isolated, for one column, one footing. Okay. But what is the allowable pressure you have? The allowable pressure is simply 100 kilonewton per meter square only. And what is the load on each column? The load on each column is 400 kilonewtons. Okay. So if that is the case, what is the area of this footing? What is the area of the footing? Okay. So let's see. Now you know that for one column, QA is nothing but whatever the load by area of footing. That's it, right? QA is nothing but QS safe na, which is nothing but gross load. Should I write all those things? QA is nothing but, see the design condition, you know it very well. What is the design condition? Q less than or equals to QS. Yes, that QS is nothing but allowable. Na? I told you most of the structures fail by shear. That is the reason by allowable I took it as safe. So now Q less than or equals to QA, then what is Q? Whatever the load coming from the column by area of the footing. Okay. Now from here, what is the area of footing I can get? The load 400 by 100, which means each footing area is going to be 40 meters square. Each footing area is going to be 40 meters square. So total area of isolated footing. And for one footing area, it is going to be 40 meters square. For one column, so I'm going to get a 40 meters square of footing area. What is the total area of isolated footings then? 4 footings into area, which means 4 into 40, 160 meters square. That 160 meters square, see, if I want to go for isolated footing, for that pressure, the base area should not be more than 40. Yes. So how many columns are there? 4 columns are there. As there are 4 columns, 4 footings. And what is the total area of isolated footing? Which is 160. And this 160 meter square is more than the plot area. What is the plot area? What is the total plot area? 10 by 10, which is nothing but 100, right? Then already this is going to be more than 100 meters square. Are you going to prefer the isolated footing? No. Isolated footing is not suitable. Okay. Then what I do is I'll eliminate the isolated footing. Then remaining a raft and combined. Yes or no? Or a raft means the entire column will be under a single footing. Yes or no? No. So if I can check a raft, I can directly check means the combined also. Okay. Now let's go with the raft. Now let's go with the raft. Hope you understood now. Okay, sorry. This is 4,000, right? This is 4,000. Even I wrote the answer correct. 4,000. Okay. So now let's take a raft footing. Sir, assume raft foundation. If I assume the raft foundation, what is the meaning of raft foundation? What is the meaning of raft foundation? The total plot area. So now the area of footing is nothing but plot, area of the plot, which is nothing but 10 by 10, which is equals to 100 meters square. That's the meaning of raft, right? What is the meaning of raft foundation? See, in the case of isolated, I find out each area. So in the case of raft, the meaning of raft is entire plot area you are going to have 14. Now, if this is the case, what is the total load? What is the total load on footing? Give me a minute, please. Okay, now there is a good news for all of you. Those who are having, I mean, as some of the, I got a call from the management only now. Okay, so they want me to say a small announcement. The classes will run as usual for offline. So whatever the announcement that is made by Telangana state government that applicable for school level, that's not for colleges or education institutions like coaching centers. So our coaching center will be running offline. So the people who are coming from various places, you don't need to worry, you can come, and the classes are going to be conducted from 5th onwards. The classes are going to be there, right? It is as usual, there is no change in that. So Telangana government has applied a stay for schools, for the primary schools and secondary schools, and for Gurukula, for Gurukul schools. For that only, that is a stay, that pill. But for the colleges and for the coaching institutions, we don't need to worry. Yes, you can come. And the second one is, yeah. Meanwhile, I'm fretting with these questions. Okay. So the second one is for the ESE students. For the ESE students, this is not for the GATE students. For the ESE students, whatever the extra syllabus is there apart from the GATE, I mean extra subjects like geology, hydraulic machines, and there is like railways. So for the extra subjects like geology, hydraulic machines, railways, etc., whatever the extra syllabus apart from the GATE syllabus is there. So for you, there is a provision, means the management is going to be allowing you a deep learn access. A deep learn access would be there. So I hope everybody knows what is mean by deep learn. So for the ACE, we have a very good recorded platforms. Those are, I mean, I'm telling you, those recorded videos are highly powerful and less time consuming than the live classes. If you ask me, you can go for that recorded classes. So, I mean, for whatever the extra syllabus is there for the extra subjects, so management is going to be provided you the deep learn recorded videos access. Anyways, they were saying me that for the general studies, they have provided this deep learn recorded access. So that will be there for the ESE students, because already the examination date has announced, right, in the February last. So that is the reason why. And if the examination date will postpone, I mean, if that examination date can postpone, then there will be the classes. But anyways, after the deep learn recording access, at the end, there will be a revision class for the ESE students for the recorded videos. Okay. But for GATE people, there is no recorded videos. For the GATE people, whatever the live classes that will be conducting, if you are online batch, and offline batches are also going to be conducting. Okay. So this is only for the ESE students. Yeah. So now what is the total load on the footing? The total load on the footing is 4 into 4,000, which means 16,000 kilonewtons. Yes? Yes or no? Then what is the total gross pressure? The total load by area of the footing, which is 16,000 by 100, but still this pressure is 160 kilopascals. Yes? 160 kilopascals. Okay. So yeah. So 160 kilopascals. Now you tell me, see, in the case of the isolated, I got to know the total area of raft is more than the plot area. But here I got to know the total pressure. So on the raft footing, whatever the columns are there, whatever the total load is there, so that load is going to be cause a total pressure of 160. Still, it is more than allowable. Fail or safe? Soil fails. That's it. So the raft foundation is not also going to be suitable. Are Baba, you tell me isolated footing is not suitable. Raft foundation is also not suitable. Are if raft is not suitable, how come combined footing is going to be suitable? How come combined footing is going to be suitable? The combined footing is also not going to be suitable. Now what is the answer? The answer is pile foundation. Pile foundation is suitable for this building. So this is how you have to check which foundation is going to be suitable for the given building and for the given soil. So I already know the bearing capacity of the soil is going to be 100. So which means I should not apply any gross pressure more than 100. Okay. Or I should not go for the footing area more than the plot area. So hope you got this. So how long we can access the recorded videos? That up to examination or after examination, I think 1 or 2 months also there would be access. So when they are giving access, they will be giving access immediately as soon as possible. Will syllabus be completed for GATE? Yes, definitely it will be completed. So what about faculties in online? Is it same? The same faculties would be there. GATE student timing for offline classes. Once you come to the offline, then they will be let you know. So I don't know what is our times. Sir, can you explain why not combine? Arey Baba, what is the meaning of combined, Ray? Combined means two columns will be combined. If for all the columns, if you combine also, it is not going to be suitable. For all the columns itself, if you go for raft, the soil is failing, then how come you believe the combined footing will take the load? No. So if raft foundation is also not suitable, then you have to go for the pile foundation only. Let's have a small break. These are the questions. After the break, we'll solve a few more uh, problems, and if time permits, we'll start the pile foundations also. Okay, have a break. Okay. Now, let's see the next question. This is one of the very good question, and see, there is a new point that you are going to see here. Everybody, yes. You see, a multi-story building. So the given is going to be a multi-story building with a basement is to be constructed. So the multi-story building with a basement is to be constructed. The top 4 meters consists of loose silt. See, I have given you here. Yes, for civil it is 6th September. I mean, from 5th onwards it is mentioned, right? From 5th na? Yeah, from 6th September. From 6th September for civil, I mean, 4th will complete it, right? So 5th, by the time you come, so there will be like 5th or 6th. So 6 would be the classes for the civil. It's in Kottapet. Kottapet. Ace Academy, Hyderabad. Okay, now let's come to the question. Yeah. So if you see over here, a multi-story building with a basement is to be constructed. Multi-story building with a basement is to be constructed. So this is a basement slab. And by the time your mind should say that this is a basement floor. Basement floor has no backfill. Okay. And the top 4 meters consists of a loose silt. Yes. See these 4 meters. The 4 meters, the soil is a loose silt. Okay. Now, and below which dense sand layer is present up to a great depth. So up to a great depth, the dense sand is present. Up to a great depth, the remaining is going to be dense sand. Okay. Now, groundwater table is at surface. Yes. The groundwater table is at the surface. Okay. I can show the same figure there also instead of every time. Yeah. Yes. Okay. Now, a basement slab of 6 meters width. So what is the width over here? 6 meters. That's the width of the foundation, right? Which will rest on the top of dense sand, which will rest on the top of the dense sand as shown in the figure. So I have given you for dense sand, the saturated unit weight of the dense sand, 20 kilonewton per meter cube, and saturated unit weight and the bearing capacity factors are going to be N cube 40, N gamma 45. For loose silt, the saturated unit weight is going to be 18 kilonewton per meter cube, NQ 15, N gamma 20. Effective cohesion, effective stresses, C dash is 0 for both soils. So for both the soils, C dash is going to be 0. Now, unit weight of water is 10. Neglect shape factor and depth factor. So I don't need to consider the shape factor and depth factor, which means we are taking home Terzaghi. We are taking home Terzaghi. Okay. So I have already mentioned you what is NQ and N gamma also. Fine. And now this is going to be like average elastic modulus is given E on Poisson's ratio you keep it aside. So what I am asking you here is using factor of safety of 3, the net safe bearing capacity of the foundation. So question number 1, the net safe bearing capacity of the foundation. This is what the question. Observe. So this is a basement slab, right? And as they did not mention anything, give me a minute, please. Fine. Okay. So now if you observe here, offline classes are not in Abits, they're in Kothabet. Okay. So now if you see, did I mention anything regarding to the size of the footing? No. As it is, I just represent the width. I just represent the width. So as I did not take anything, so I have to assume it as a strip footing. They did not mention it as a square. They did not mention it as a circular or anything. So as per Terzaghi, so I have to take it as a strip footing only. I have to take it as strip footing only. So first thing first, the question is, what is the net safe bearing capacity? You know that the net safe bearing capacity is nothing but net ultimate by factor of safety. Yes. And now you please tell me the net safe bearing capacity is equals to what is net ultimate? You know, as per Terzaghi, net ultimate. So CNC strip footing. Sir, why you are taking strip footing, sir? Because they did not mention anything regarding to the length or sizes. So CNC plus gamma D into NQ minus 1 plus 0.5 gamma B and gamma by factor of safety. By factor of safety. Okay. Listen to me. The entire soil is under submergence. When the entire soil is under submergence, then I have to write as gamma dash, gamma dash. Okay. And above soil, this is silt, gamma dash of silt. And below, this is nothing but sand. Now, up to this, I hope you understood. Yeah. Now, if you observe, the main point over here is, Are Baba, for loose silt, I have given NQ and gamma. For dense sand, also I have given NQ and gamma. For loose silt, I have given NQ and gamma. For the dense sand, also I have given NQ and gamma. So now my question for you, sir, as per Terzaghi, you said I know the equation, but the biggest point here you need to understand is which NQ and gamma I have to take. Should I have to take the loose silt NQ and gamma? Should I have to take the dense sand NQ and gamma? To think and say which NQ and N gamma I have to take. Should I have to take dense sand or loose sand? I mean, should I have to take dense sand or loose silt? If you do remember, what is the Terzaghi's theory assumptions? Terzaghi has done his analysis on strip. Fine. And the one of the assumption, soil above the base of footing is just considered as a surcharge. Have we taken the side resistance of the soil? No. So the resistance of a soil above the footing is ignored, which means whatever the soil above the base of footing, it will just act as a surcharge only. Gamma dash of silt into D, that's it. It won't create NQ, N gamma, N means we should not use NQ, N gamma or NC values of loose silt. So as per Terzaghi, soil above base of footing is considered as surcharge and its resistance is neglected. So now which NQ, N gamma I have to use? So properties of soil, bearing capacity, factors of soil below footing only considered, which means dense sand NQ and gamma only. So now this is just completely to confuse you. There is nothing in this question, but they have given loose silt NQ and gamma, dense sand NQ and gamma, so as to make you confused. So now I hope it has been cleared for you. So which one I have to go for? I have to go for dense sand. I have to go for dense sand. Okay. So no, now what is NQ value? What is NQ value? NQ value given as 40 N gamma 45. Okay. Now you take the same equation. You take the same equation. Yes. So QNS is equals to CNC. Anyways, C is equals to 0. So gamma dash, what is the gamma sat of silt? 18 and 10. So which means 18 minus 10 into 4 into 40 minus 1 plus 0.5 into what is gamma sat of sand? 20, right? 20 minus 10 into B value. What is the base? The base is 6 meters into N gamma 45 by what is the factor of safety? The factor of safety is 3. So find out the net safe bearing capacity. Find out the net safe bearing capacity. Which comes as 866 kilopascals. That is the net safe bearing capacity. So the answer should be 866, but there is no answer. There is no answer in options. Actually, the actual procedure is this one. The actual procedure is this one, but the examiner has given the question. You see, he asked about the net safe bearing capacity clearly, but whatever the answer he has given is the safe bearing capacity. Whatever the answer he has given is for the safe bearing capacity. So the correct answer is going to be 866 kilopascals. This is the correct answer, but in the given options there is no answer. In the given options there is no answer. Hope you understood. Why I took this question is then this was a question which was asked in GATE 2013. Okay, so definitely the people, if you have I got to know that I was sorry, day before yesterday I told you one of the previous GATE question which was given as a wrong answer. So for that, everybody they have awarded marks. For everyone they have awarded the marks, whether you have attempted or whether you did not attempt it. So if the GATE question, whatever the question framed by the IIT, if they give the wrong answers, whether you attempt or whether you don't attempt, they will provide you the mark. So I told you a few days back, those who have attempted, those got the free marks. It's not true. So everybody will get the same marks and those marks will get normalized. And you see the next question for the same way, for the same thing, bonus marks this is. Yeah. So if you go for safe, that is going to be, by taking soil factors. Yeah. But the correct answer is this one, 866. Okay. Now, the foundation slab is subjected to vertical downward stress equals to the net safe bearing capacity derived in the above equation. So in the same question, whatever the foundation slab is going to be having whatever the foundation slab is subjected to vertical downward pressure equals to net safe bearing capacity using influence factor 2, neglecting embedment depth and rigidity corrections. The immediate settlement of the densest sand will be, what is the immediate settlement? The immediate settlement is nothing but net pressure by E into B into 1 minus mu square into I. I hope you remember, right? And if you observe, I have already given the average elastic modulus E value and Poisson's ratio of denser sand is so 0.3 and 60. You know that B is equals to 6 meters. 60 into 10 to the power of 3 kilopascals. And Poisson's ratio is 0.3. And what is I value here? It is mentioned as 2. And neglecting the rigidity corrections also. You don't need to apply any rigidity corrections. Directly you can simply substitute. But in the given question, whatever the net pressure, it is given as a net safe bearing capacity, because the net safe bearing capacity is going to be used. So what is immediate settlement? The immediate settlement is like, what is net safe bearing capacity? We got 866 by 60 into 10 to the power of 3 kilonewton per meter square into B, 6 into 1 minus 0.3 square into I value as 2. What is the immediate settlement? What is the immediate settlement? Point 1576 meters, which means 150.6 mm. So this is the answer. Again, no answer. So you see, 4 marks you got. That was a linked type question before GATE 2014, right? Up to GATE 2014. I mean, yes. So in GATE 2014 only, they have introduced this online system. And before GATE 2014 up to GATE 2013, the paper was like offline, and you have to write the examination offline, and you have to use a OMR sheet, just like how you attempted JE or MSET, I mean, whatever the state service examination. And at that point of time, there was a questions like a linked answer type, which will give, right? They give you data, something like this. They will give you 2 questions for that. And if you do first question wrong and second question correct also, you don't get any positive mark. In fact, you get negative marks. So the first question should be correct. So you have to attempt the first question correct. I mean, these models were there prior to the 2014 GATE, but from 2014 GATE onwards, there are no linked type questions. Now you see this question. A square footing of 2 meters sides rests on the surface of homogeneous soil bed. A square footing of 2 meters. So given is a square footing. Okay. Why I have given this question? You see, width is 2 meters. Homogeneous soil bed having a cohesion is there, 24 kilopascals. And now what is phi? Phi is 25 degrees, which is less than 28 degrees. Then is it a local shear failure or punching shear failure? Oh, sorry, general shear failure. This is a local shear failure. And you see, the unit weight I have given as gamma. What is unit weight? 18 kilonewton per meter cube. And for the Terzaghi bearing capacity for phi 25 degrees, I have given NC, NQ, and gamma, NC dash, NQ dash, and gamma dash. The ultimate bearing capacity I'm asking you. You tell me, normally the equation, that's a square footing, right? As it is a square footing, 1.3 CNC plus gamma DNQ plus 0.5 gamma B and gamma. But you see, if you miss the point over here, this is a local shear failure. Yes, as it is a local shear failure, you tell me, should I have to use CM or phi m? CM. Should I have to use NC or NC dash, NC dash, NQ dash, and gamma dash? That's it. Sir, how I got to know that local shear failure? Because phi value is less than 28 degrees. So what is CM? The CM is 2/3 of C, 2/3 of 24. So what is the CM value? Like so 8 3s 8 to 16 kilopascals. Yes. And what about phi m? Do I need to find phi m? No, it has already mentioned for that phi value. What is NC, NQ, and gamma? And what is NC dash? NC dash means that already they have find it for the phi m dash. So what is QU value? 1.3 into 16 into NC dash 14.8 plus gamma 18 into is rests on the surface, right? I'm sorry for that. Rests on the surface. So it is rest on the surface. So as it is rest on the surface, then simply I can take D0 because rest on the surface. So D is equals to 0 plus 0.5 into 18 into 2 into 3.2. So find out the ultimate bearing capacity. So this is 0.4, right? This is 0.4. Sorry. So come on, solve it. 1.3 into 16 into 14.8 plus 0.4 into 18 into 2 into 353.92 kilopascals. You don't need to round it off because whatever the value you get itself is 2 decimals. You have to round it off, the round off to 2 decimals. They are not asking round off to nearest integer. They are asking round off to 2 decimals. Mr. Lekkal Demudu Naidu, in previous question, neglect effect of the depth and width. Na, sir. Who said, Arey Baba, that is a shape factor and depth factor. What is the meaning of shape factor and depth factor? SI, SC, SQ, DI, DC, DQ. Those will be neglected. Who said that width is going to be neglected? So that's all about the previous gate questions from this chapter. So whatever the questions, apart from the questions that I have solved in the classroom. So if you round it, how many marks will you deduct? You lost 2 marks as a positive and you gain a 0.61 marks as a negative. So obviously you will be in loss. This is about previous gate. Now let's see some of the previous ESC questions. So today I will conclude this everything and then when Okay, fine. I cannot start today Pile Foundation. I thought of starting the Pile Foundation, but I don't know, somehow my jaw is paining. So I cannot start a new topic, but I can end the Shallow Foundation. I thought of like planning to give the introduction for the Pile Foundations also, but I cannot today. Anyways, we can. And one more thing I'm asking you, surveying class completed for you? Surveying class completed for you? Yes. So if surveying class is completed for you, so today is Tuesday, right? Wednesday, Thursday, and Friday. Okay, what we'll do is on Friday and Saturday morning, let's say 10 a.m. to 1 p.m. only for ESC students. So for Friday and Saturday, 10 a.m. to 1 p.m. only for ESC students. So whatever the extra syllabus are there, which is nothing but well foundations, foundations on expansive soils, and geosynthetics, sheet piles. So whatever the extra topics are there that I will be discussing on Friday and Saturday. So this is only for the ESC students. I hope the ESC students are. I hope they can come. Yes, this is not for gauge. This is not for gauge. When we are going to solve the 2021, yes, we are going to solve the 2021 questions on Saturday. See, probably my plan. So today we will complete the. Today we will complete the shallow foundations, and tomorrow, Wednesday, Thursday, Friday. Wednesday, Thursday, Friday, 3 days will complete the pile foundations completely. And on Saturday, see, Saturday the class would be full day. On Saturday, the class is from 9, sorry. Or okay, I'll take it as on Saturday, 9 o'clock. Friday and Saturday, so I'll take it as 9 a.m. to 12 p.m. 9 a.m. to 12 p.m. On Saturday, 9 a.m. to 12 p.m. You please remember this. On Saturday, 9 a.m. to 12 p.m. for ESC only. For ESC students only. And from 2:30 to 8:30 p.m. everyone. Regular batch, gate plus ESC, and college goers, whatever, whoever is there, everybody, you have to come on 2:30 to 8:30. We are going to finish it off on Saturday, and we don't leave anything on Sunday. So, I mean, I already buffered the time. I know that some time would be lost. So I already buffered the time. So 3 days, next 3 days, we go for the 4 days are there for us. So I'll do one thing like tomorrow, Wednesday, Thursday, Friday, 3 days we'll be completing the pile foundations. If there is a possibility, we would be completing earlier than that also. On Saturday, 2 to 8:30, 2:30 to 5, one session, we'll complete the soil exploration. And already for the ESC people, I'm going to take on Friday and Saturday in the morning session. We'll be completing the extra syllabus, whatever the extra syllabus that is there for the ESC students. So this extra syllabus I'll be completing on Friday and Saturday morning. So By Saturday afternoon, we will be left over only one chapter, soil exploration. And in Saturday, by means from 2:30 to 5 o'clock, we'll be completing the soil exploration. And from 5:30 to 8:30, previous year's questions of GATE 2021 and GATE 2020. So with that, comfortably, conveniently, convincingly, we can complete the geotechnical engineering. So this is my plan. It's fine, right? I think it's fine for you. A revision will be done on that. See, yeah, revision will be there. Revision. See, this is a tentative schedule. If everything goes well, we would be completing the pile foundations before Friday also, or on Friday we can complete the pile foundations. Pile foundations require around 7 hours. 7 hours or 7 to 8 hours of pile foundation will require. Tomorrow 3.5 hours, day after tomorrow 3.5 hours. So possibly we can finish it off. So don't worry. Whatever I promised you, so I told you I'll give you revision, and I told you I'll solve the previous year's question. We'll try to do it maximum. Okay. So don't worry about that. So now let's see this. Come to the previous gate questions. Yeah. So Terzaghi bearing capacity theory is not applicable for the deep foundations. Yes, true, because he assumed soil fails by general shear failure. So Terzaghi assumed soil fails by general shear failure, which can be seen in only shallow foundations. Assertion is true. Shear strength is mobilized on the sides of the deep foundations. Yes, I told you deep foundations has a more load carrying capacity due to friction developed between the pile and the soil on sides. Yes, true. But does the reason is a correct explanation for you? No. In pile foundations, strength developed on sides. True. In shallow foundations, why Terzaghi went for only shallow? Because he assumed soil fails by shear, GSF. So both are true, but reason is not a correct explanation. Both are individually true, but reason is not correct explanation. Now let's see this question. 4 square footings B by B. 4 square footings are B by B. So there is a score. So each carrying a loading intensity of Q are spaced close enough. When they are placed very close enough, what is a significant depth? You know what is the meaning of significant depth? The meaning of significant depth is nothing but depth of the pressure group. Yes or no? What is the meaning of significant depth over here? As they are closely spaced, their pressure bulbs will get overlap. As they are closely spaced, their pressure bulbs will get overlap. So for the total soil, as it is a square footing, for square footing, the significant depth is 1.5 times 2 times of the width. Yes. And if it was a strip footing, the significant depth is nothing but 2 to 3 times of the width for the strip footing. So the answer is going to be 1.5 times of the capital B, not small b, because for small footings it is B. What is the total width? Capital B. As footings are closely spaced. So we have to take total width as capital V. That's it. Fine. Let's see this question. As the bearing capacity of a strip footing resting on cohesive soil. What is the bearing capacity of a strip footing resting on cohesive soil for unit depth 1 and unit width 1 meter? Okay, and assume so the bearing capacity of a strip footing resting on a cohesive soil for unit depth and unit width. Anyways, the meaning over here, the bearing capacity is net ultimate bearing capacity. Why? Because you know QU is equals to CNC plus gamma D and Q plus 0.5 gamma B and gamma. That's for the strip. As it is a clay, N gamma is going to be 0. And QU is equals to CNC plus this is 1 and depth also given as 1. Did they mention any gamma value? Did they mention any gamma value? No, right? So you just take it as gamma into 1. The net ultimate bearing capacity is equals to CNC. Actually, the bearing capacity represents net ultimate bearing capacity only, because what is meant by net ultimate bearing capacity? The maximum pressure that the soil can take, the maximum net pressure that the soil can take without any failure, without any shear failure. So answer is going to be 5.7 into 10. Answer is 57. Answer is 57, as I don't have any unit weight of the soil mass. As I don't have any unit weight of the soil mass. Okay. Now, you see this question. A rigid strip footing is subjected to vertical central load under general shear failure. So you know whatever the footing that we have discussed according to as per Terzaghi. So this is a rigid. You know that base of footing is rigid, and you know soil fails by general shear failure. So first there is a plane and radial shearing, and the soil fails like this. Yes. So this is nothing but log spiral, right? Whatever this zone, this is 1 and this is 2 and this is 3. So whatever, this is nothing but the failure surface, right? And the failure surface shape is log spiral. In the case of the radial shear zone, the shape is nothing but log spiral. It's not circular. Okay. Circular one-sided rotation failure. No, it's not circular. Plane surface of failure originating at the edge of the footing and extending downwards with the orientation of Rankine's passive state equilibrium. Symmetrical failure surface consisting of a segment of spiral and Rankine. So it's a symmetrical, right? You observe in both the sides, you can see it's a symmetrical one. And you know that it is going to be start as a symmetrical, yes, symmetrical failure surface consisting of a segment of a spiral. So whatever, this is nothing but spiral. This shape is nothing but log spiral. And Rankine's passive state failure surface. Yes, option C. Symmetrical failure surface consisting of a segment of log spiral and Rankine's active state. No, it's not Rankine's active state. It's a Rankine's passive state. Okay. Yes. Understood? Now this is beautiful question, and based on this question only in GATE 2020 they asked a question. You see, this is a strap footing. So you know the meaning of a strap. We are going to provide some strap at the top. We provided some strap at the top. Okay, so on one footing it is going to be one column 3000 kilonewtons, other column 4500 kilonewtons. It's not straight, my dear. It's a symmetrical failure on both sides. What is the length of the left footing? what is the length of the left footing? So the length of the left footing I am asking you. You see, you observe over here, take width of the both footings as 3.5. Take, see that this is nothing but left footing, right? So take width of the both footings as 3.5 and safe bearing capacity as 350. So you know the safe bearing capacity over here. And if you want to find out the safe bearing capacity for left footing, you know that safe bearing capacity is nothing but whatever the reaction over here, you please observe the safe bearing capacity, the reaction R1 by area of footing. The reaction R1 by area of footing. As there is a strap, now the reaction is not exactly at the center. And now, how to find out R1? How to find out R1? So if I take in a plane, this is now from the mechanics. This is a plane where here this is 3000 kilonewtons and this is going to be 4500 kilonewtons. Now there is a reaction R1 here and there is a reaction R2 here. And now from here to here the distance is going to be 7 meters. And what about this value? This value is just 1.2 meters. Now how come I find out R1? How come I find out R1? You just tell me, how come I find out R1? If I take a moment about this point C, so let's take this as point C. If I take moment about the point C, see these type of questions. So when they give loads, moment, something like that, you know, take moment about points. If you take moment about point C, then the clockwise moment is going to be 3000. Into distance is 7. So here this is a clockwise moment and the anti-clockwise moment is nothing but R1 into 7 minus 1.2. Please find out the R1 value. Please find out the R1 value. R1 is 3000 into 7 by 7 minus 1.2. So the R1 value is reaction 3000 into 7 by 7 minus 1.2, which is 3620.69 kilonewtons. Yes. Okay. So now, if this is the case, then I can find out the area of the footing over here. So QS is equals to R1 by area of footing B1 into L1. So I want the length, right? What is R1? 3620.69 by, what is the width of footing? Both footing 3.5 into 350. Tell me the length, please. .95 meters. Answer is 2.95 meters. 2.95 meters. Okay. Without calculator, how to solve? See, 3000 into 7 by 7 minus 1.2. So 7 by around 6. Yes. Let's remove that 1.2 as 1. So what I do is 7 by 5.8. No, I'll take it as 7 by 6. 7 by 6 means how much? So you have to solve 7 by 6, which means 1.167. Yes. So 1.167 into 3000, which is going to be more than 3500. More than 3500. Okay, whatever the value you get over here, you know, see, listen to me, you know, this value is going to be more than 3500. If I take nearest value, more than 3500. Now you substitute over here, more than 3500 by 3.5 into 350. Then this is going to be 10 times. Yes. And answer should be more than 10 by 3.5. 3.33 into 3.33, that's 10. And more than 10 by 3.5, which is going to be almost is equals to 3. Almost is equals to 3. Then if you see the answer is going to be almost is equals to 3. So the nearest value is 2.95. Okay. No, fine. Now you see this question. A raft foundation are the best type of shallow foundations to support heavy structures. Yes. To support heavy structures, raft foundations are the best type of foundations. Because if the load is going to be getting high or heavy and heavy, the isolated or combined footings cannot take. So you have to go for the raft. And one more thing, if you go for the raft, due to that heavy loads, it will prevent the differential settlements. Yes, raft foundations have the ability to redistribute the load coming on weak pockets of soil below raft to the adjacent soils, because in the case of the raft footing, so it is going to be distribute the soil load in such a way, weak soil gets less load, strong soil gets more load, where the stresses are less severe for the soil at that place. This reduces the chances of differential settlement and increases the bearing capacity. More the width, more bearing capacity. And as I provide for total columns as single foundation, reduces the differential settlement. So this is true. A and R are true. And R is correct explanation of A. Okay. Now, in a plate load test, how is the ultimate load estimated from the load settlement graph log? I told you in the case of the log graph, it is going to be directly yes or no. So directly I can measure. Answer is directly. By drawing tangents to the curve at initial and final points, that is for normal graph. In the given question, instead of log, if I would have given the normal graph, then by drawing tangents to the curve at the initial and final points. And last, which one of the following zone is logarithmic spiral shape of the failure surface? Which one of the following zone is a logarithmic shape? Just now, I mean, one of the question I mentioned you. Yes, the radial shear zone is a log spiral. I told you, right? Active zone, there is no active zone. Passive zone is not log spiral. The radial shear zone is a log spiral. The radial shear zone is going to be the log spiral zone. Okay. That's all for the previous GATE and ESC. With this, we completed the shallow foundations. The one major chapter left over is deep foundations. And in deep foundations, there is one extra topic added in last year. That's laterally loaded piles. We'll see everything tomorrow. Okay. And I cannot take, I don't know, I'm getting more of jaw pain, and I hope you can see the, I'm not feeling comfortable also. So for today, we'll stop here. So take Friday also 6 to 8, even the network on Sunday, you can manage. That we'll see tomorrow. That I'll yes. Okay. Fine. I'll stop the session now and. See, those who wants to continue online, you can continue online, and those who wants to come to offline, you can come to offline. There is no force like you need to come to offline only, you have to be in online only. If you wish to be study in offline, then you can be. Okay. So that's all for today, and I'll leave the session. I'm sorry, I cannot take any doubt reading session today. Good night. Good night for all of you.